let's start, guys. So last time, guys, I explained what I did last time was I told you, I explained how can you program the keypad on the Dragon board. I give you one example in some application how we use this keypad. Actually, you can see by yourself. You can you in many applications, right? You use the keypad to, for example, if you have a system that can open a door or not, I can use a keypad to enter your pin number, and if the pin number is okay, you open the door and so on, right? Also in the vending machine, in order to buy something from the machine, you have to select the item. So we use a keypad to select the item, right? So this is how in embedded systems we use keypads, right? You want to get some numbers from the users. So I explained number one, how it is connected. As I told you guys here, as we see, it is connected to port A. And I told you about the interesting idea we do here. I told you we use four pins input and 4 pins output. Okay. And okay, let me just, sorry. Yes. Also, I told you how it is connected. So you have here wires, 4 rows and 4 columns, as you see here, guys, and they are not connected. Okay, here. However, in every intersection, we put a switch, like a button like this one. So this button, every button here at each intersection, right? But again, there is no electrical connection here, right? The idea is that when you press a button, you actually create a short circuit between one row and one column. Okay, and now I have to write a code to see where is this short circuit. So, for example, as I explained last time, guys, if I press this button, so the short circuit is here, right? So I need to scan. Look at the word scan because I don't know where is it. So I have to try, right? So number one, I'm gonna put one here. If none of the switches here is connected, that means this one is not gonna come here at the input, right? So I'm gonna output here one. If none is connected, so it's not in this row. So I have to try next one. So I'm gonna put the one here. If still the one didn't appear here, or if this one the one or here 1 or 5 volt, you understand that, right? When I talk about logic, it is one. When I talk about pins or a physical world, I mean 5 volt. So if I put here 5 volt and there is no 5 volt here, that means none of these switches is connected, simply because if any switch is connected, this 5 volt should be connected here, right? Because the switch is going to make a short circuit between one row and one column, right? So I have to try this way. So like again, when I put it here, yes, because the switch is here, yes, I found it here, right? So I need to know which row is connected to which column. After that, I have to extract the ASCII code of this switch. Okay, and as you see here, guys, every button here is connected to a unique pair of row and column, right? So once I know the row, the column, so I can locate or I can know the button, because every button has a unique row and column, right? So this was the main idea. The interesting part here, guys, is you look at the code, it's long code, right? The code is long. However, because the microprocessor is fast, you are not going to notice any delay. You just press the button, okay? So you just get the number right away. So you are not going to notice any delay. You got what I'm saying? And this is very interesting. This is how it is. You can do a very complicated things using computers, and these computers can do it very fast. Again, this is because computers are fast. So although, look, we do a lot of things here. You search, you scan, you try the first row, you try the second row, you try the third row, and so on. So you do a lot of things, but this is done very quickly. You don't need even observe any delay when you use it. Okay. And as I told you, next week lab will be about using keypad and LCD. So I'm gonna also explain LCD today. Okay, guys. And so I explained everything. I explained this subroutine, which is called keypad in assembly, right? So I explained everything, and um, um, I told you, um, this is the code here just for your knowledge, or if you want to learn more assembly and so on. But what I care more here is how can you can use the keypad. Okay. And the way you can use the keypad is very trivial. All what you have to do, guys, just call a subroutine called keypad. That's it. Once you call a subroutine called the keypad, you don't even need to do configuration. Although in this example I did a configuration here, you don't even need to do it because this instruction I already wrote it in the subroutine. Is that okay? So you don't even need to do this configuration. Just very simple. It cannot be easier than that. Just you call a subroutine. After you call the subroutine keypad is gonna wait until you enter a number until you press a button. Once you press a button, it returns the ASCII code of this number in register A, right? And I told you as well last time, here, sometimes, listen to me, guys. So now, as you see here, we have number from 0 to 9, right? This is numbers, but again, this is hexadecimal numbers. I'm talking about the decimal numbers. So the decimal numbers we have between 0 and 9. Actually, what keypad is going to give you is going to give you ASCII. So it's going to give you a number from 30 to 39, right? So again, sometimes I need ASCII. Okay, so this is what the keypad is going to give you. Sometimes I need a number, not ASCII, right? So because keypad is going to give you ASCII, how can you get a number? That's very trivial. All what you have to do, you have to subtract 30. 30 is hexadecimal, and this one is hexadecimal, right? So all what you have to do, just subtract 30, because 30, if you subtract 30, you get 0, right? 39, when you subtract 30, you get 9, and so on. Is that okay, guys? So converting ASCII to number, very easy. So tell us when you need to have ASCII and when do you need to have numbers, right? I need ASCII, as you will see right now, if I wanna display this number on the LCD. Okay, so if I wanna display, for example, the number you get from the keypad, I wanna display it on the LCD. LCD can only understand ASCII numbers, so you have to send it ASCII number. For example, if I wanna display number 7 here, I should not send the 7, right? I should not send 7. I have to send the ASCII of 7, which is 37. Is that okay, guys? Same thing for any number, okay? So I need ASCII. If you want to display this number on the LCD, you have to send it in ASCII, this number 1. Now, when do you need a number from 0 to 9? Usually I need a number if you want to do computation. For example, I got a number from the user. I'm going to multiply this number by 1000 and divide it by something, and then use this number in something, right? So if you want to do like a mathematical operation and you want to get a number from user and use this number, right? So that's, you have to convert from decimal, from ASCII to a number. Okay. So that's what I explained. It's, as I told you, just very trivial. All what you have to do just to call a subroutine, right? Now I also move to C language. Same thing for C language. We have a number of subroutines. We are going to use these subroutines. The first one here, the first subroutine is, let me, keypad enable. Okay, so this one, keypad enable, this one should do initialization, and you have to do it one time in your code. So if this is my program, I'm going to explain it right now. So you can just you have to put it only one time, keypad enable. So this one is going to do initialization to the keypad, right? So just one time initialization, that's okay. So this one, the second one is called get key, right? This one is identical to keypad in assembly, but the difference is in this one is gonna wait until you press a button. This one is gonna return the number, not ASCII. You got what I'm saying? So here, this one is number 1, number 2, number 3. This number 10, right? 10, 11, 12, 13. So it's gonna return a number from 0 to 15, right? Number from 0 to 15. Now, if you wanna convert, if you wanna convert this number to ASCII, you have to write a code to do that, right? You have to write a code to do that because the idea is, if you get a number from 0 to 9 and I want to convert it to ASCII, so I have to add 30. Is that okay? Because it should be like from 30 to 39 hexadecimal, okay? But if you wanna, but if it is A, B, C until F, the ASCII of this one is 41 hexadecimal, 42, and so on, right? So now, so it gives you a number. How can you convert to ASCII, right? I'm gonna tell you two solutions. You can select whatever you like. The first thing you can do is you have a function here. Can you see this function, guys? You can just use this function. That means if I put here in this function, so here I have to send the argument I have to send to this function is a number, right? From 0 to 9 or actually from 0 to 15, okay? From 0 to 15, and then this one is going to return, this function is going to return the ASCII of this number. So if you send 0, you get 30. If you send 9, you get 39, and so on. If you send A, you get 40, and so on. So this is one idea. You can after you get a number from the user here, you can just put the number here in this function, and this function is going to convert it and return it to you, the ASCII of this number. You can do that, right? Or there is another way I'm going to explain right now, guys. In this program, I can create array this way, and then after I create the way I put here the elements in this array is in every element I'm going to put the ASCII of the corresponding number. For example, in element 0, I'm going to put the ASCII of 0. In element 1, I'm going to put the ASCII of 1. In element 7, ASCII of 7. 9, the ASCII of 9. 10, I'm going to put A, the ASCII of A, the ASCII of B, the ASCII of C, all the way until the ASCII of F. So all what you have to do, guys, once I get a number from you, I'm going to go to, this is the array, I get a number 10. So I'm going to go to location 10. I'm going to get the ASCII from there. Just another idea, okay? Whatever you like. Both ideas are okay. Either you use a table, array or a table like this one, as I'm going to explain right now, or you just call a function this way, okay? Also, what I explained last time, we have another function. It's called wait key up, and usually I couple this one with this one, so I use them together. Why? What is the difference between this one and this one? I'm gonna or how they complement each other. I'm gonna tell you. If I press a button and I hold for some time, right? If you call get key is gonna give you this number, right? If you call it again, you are gonna get the same number. Although I didn't press twice, right? I'm just holding, right? So if you call 3 times, you're gonna get the same number. If that's okay for you, it's okay, right? However, usually we don't do it this way. Usually, if you wanna enter the same number several times, you have to press, release, press, release, press, release 3 times, okay? To do that, after I call this function, I have to wait until you release. You release your finger, right? Until key up. You got what I'm saying? By this way, I'm gonna force you have to press and release, okay? The problem here, maybe you press 1 time, but because the problem here is microprocessor is fast. Maybe I press 1 time, but you are gonna take it, the program is gonna take it like you pressed it 3-4 times, which is not true. You got what I'm saying? So usually what, as you will see right now, usually I'm gonna use these two together. After I get a number from you, I'm gonna wait, I'm gonna hold here until you release it, okay? And then after that, I can get another number from you if I want. The last one, which may not, we 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 may not need it, but this one, if you call this function is not gonna wait like this one. This one is gonna wait like keypad. This one is not gonna wait. Once you call this function, it's gonna go to the keypad. If you don't press anything, it's gonna return a number 16. Otherwise, it's gonna return a number from 0 to 15. So if you press any number, it's gonna return this number from 0 to 15. If you don't press anything, it's gonna return 16. Okay, guys? Any questions?
I have a question about calling these from the like the key scan, not key scan, but the keypad in assembly.
Yes.
Whenever you used, yeah, right there, BSR keypad. Whenever I try to do that, when I have the keypad in a include file, it tells me that I have that it's too far away in memory.
Yes, yes, that's a very good question. Thanks for raising this question. That's why I am begging you to ask me questions. That's okay, right? Because I am I am like you. I want to enjoy teaching. Okay, I'm not teach. I'm not only teaching to just because it's my job and to get money. I'm enjoying it. Okay, and I enjoy it more when you ask me questions. Anyway, so thanks for this question. That is true because you used the branch subroutine, and as I said before, branch subroutine is just if it is short, if it is if keypad is short, but and it may be okay in this program because this is a small program. However, in your program, it's a long program, and that's why it's give you error because it's not short. That's why what you have to do, you have to say jump subroutine, right? Instead of branch subroutine. If you do that, you're not gonna have this problem. Okay, guys, is that clear?
That makes sense. Yeah, thank you.
Yes. So try jump subroutine and see. I think you should be okay because it should be long, long branch. So it should be okay. Okay, guys. Now I'm going to teach you how can we do a program in C language. This is the same program I taught here. If you remember last time I told you and I ran the video last time. In this video, when you press a button in the keypad, I want to display the value that's going to be returned from the keypad. I want to display it on the LEDs, which is ASCII for sure. This one returns ASCII, right? So I want to display the ASCII on the LEDs because I just want to test the keypad to make sure it's working. The way I did it here, I'm going to jump a subroutine. Once you jump the subroutine is going to wait until you press a button, and the ASCII of this button should be in register A, and then you can copy register A to port B as you see here, and then I'm going to keep repeating that. So I'm going to call this the subroutine, get a keypad and send it to the LEDs. Okay, very simple. So I want to do the same thing here, but there is a small difference. As I told you, the small difference is here. I'm not gonna get here. I'm not gonna get the ASCII. I'm gonna get a number from 0 to 15. So the number I will get from the keypad, I'm gonna convert it to ASCII, right? So as you see here, the way I did it, guys, again, number one, you have to use this one. Every time you use the keypad, you have to use this one, right? This is keypad enabled. This one should do initialization to the keypad, should initialize register A. By the way, as I said before, guys, all the functions I'm teaching in C language are written in assembly, right? So I encourage you to open this function and look how they are written in assembly. You can understand them, right? And even if you want, you can modify them very easy, right? So there is a tutorial on the course website. This tutorial can tell you if you want to see the content of this function, how can you do that, right? Anyway, so the content is written in assembly. So every time you want to use the keypad in assembly, you have to use a keypad enable this one this way. Okay, guys, this is number one. Number two, now this is the subroutine. Let me remove this one. Yeah. So here I'm gonna have infinite loop. I'm gonna keep looping here. I'm gonna keep looping. See how I made it? I can C equal get key, right? So here I'm gonna call the function get key. Get key is gonna return a number from 0 to 15. I'm gonna store it in a variable. I'm calling it C, right? And then after that, because this is a number and I don't want to display a number, I want to display ASCII, so I have to convert this one to ASCII, right? The way you can convert it, guys, you can do something like that. You can call a function hex to ASCII C, right? So this function is gonna return the ASCII of C, right? And then this return value I want to send to port B. So I can say this one I can write in a different way. I can say port B is equal to hex to ASCII of C, right? So here, this one is gonna take a number, is gonna return a ASCII. The ASCII, I'm gonna write it in port B. Is that okay? Very easy. Again, there is another way to do it. This is programming, guys. If I'm a good instructor, especially in programming, I should not be very limited and teach you very limited ways. It's a good idea in programming to learn different ways. Okay, so there is another way you can do this way, or there is another way. As I told you, you already have array here, right? So I can write the same sentence here in a different way. I can say port B is equal ASCII, right? This is the array of C, right? So I'm gonna get, this is the element number, and this is the value stored in this element number, which is the ASCII of this element number, and then I'm gonna put it in B. Okay, you can do this way. Okay, and also I told you before, you can say port B equal whatever, or if you like more functions, you can say LEDs on. It's the same thing. So if you say LEDs on and then you put some value here, so this one is exactly equivalent to port B is equal to this value. So whatever you like, you got what I'm saying? So so let's see what I did here. Here, okay. So I'm gonna get C, which is a number. This number I'm gonna send it to here. I'm gonna convert the element number to value, right? And this value I'm gonna send to this function. And I told you this function, whatever you send here is gonna put it in port B. Again, in C language, if you wanna write it port B this way, totally fine. If you wanna LEDs underscore on and you put here this value, totally fine. Whatever you write here should be sent to port B. Okay, guys. And then after that, here I'm gonna wait. Okay, sorry. So again, I got a number, a keystroke from the user, put it in C, and then I sent it to port B. I convert it to ASCII, and then I sent it to port B. So I'm almost done, right? So here I'm gonna wait until you release, right? That is because what happens, I don't want to the subroutine here to keep looping. So if you press and you hold for 1 second or half a second, right? Half a second is a very long time for computer, right? So during this half a second, so the computer can call this one 5-6 times, right? So it's gonna keep looping or several times, right? So I'm gonna hold here. I'm gonna wait until you release. After you release, I'm gonna go back to the beginning again. Okay, guys. So we don't have a function like this one in assembly, but still you can do it, right? So if you want to do it in assembly, the way you can do it is, look, you remember when I try to test if any button is pressed this way, guys. So I can put here 1-1-1-1, right? If the result is 0-0-0, that means you released, right? So the way you can do it here, what I can do, number one, as you see here, so I can move this value to port B, as you see here, and then I'm gonna read port B, and then I'm gonna do AND operation. Look here, guys, and then I'm gonna compare to 0. But now I'm gonna say if it is not equal, if not equal to 0, keep looping, right? So I'm gonna wait. I'm gonna keep looping until this is 0. And these are 0 when you release. You got what I'm saying? So this, what I explained right now, guys, just focus with me. This will be something equivalent to keypad up. Sorry, wait, key up in equivalent to this C function, the equivalent one if you want to do it in assembly, if you want to do the same thing in assembly. Very easy. All what you have to do again, guys, number one, I'm going to output 1 1 1 1, right? And then I'm going to keep looping until I find 0 0 0 here, because 0 0 means you released, right? You released the button. So I'm going to use exactly same code here, but with a small difference. Exactly same code like this part, right? I'm going to move this one here. I'm going to load port A. I'm going to do AND. I'm going to compare to 0. But now I'm going to say if it is not equal, branch. If not equal, so keep looping. So the only way to leave here is if the value here is 0 0 0. Okay, guys. Any questions before we move to the LCD? Any question, guys? Great. Now let's move to the LCD, right? So as you know, let me go back to the picture that has just, yeah, give me 1 second. I think, yeah, this picture. So if you look here, I think I cannot, let me discard, okay? And I'm gonna delete this one here. Okay, great. Look here, guys. This is our Dragon board, okay? So, okay, so this is our Dragon board, guys. I already explained here. I explained several things. So I explained the LEDs, guys. Oops. I want to make it red. Okay. So I explained how can you program LEDs. I explained how can you program the switches. How can you program the buzzer. It was very interesting. Also, I explained how can you program the keypad. Also, I explained how can you program RGB LEDs. That's what I finished. Now I'm going to focus on LCD. So what is left here? What is left? So I didn't teach yet how can you program the push button. We have 4 push button here. I didn't explain them yet. I will do that. What else? We have a relay here. That's very simple. So we have a relay. I'm going to do it as well, right? But let me first finish the LCD. So as you see here, guys, we have a LCD here. I'm going to explain as usual. Number one, I have to tell you how it is connected, how the hardware is connected. Number two, I'm going to explain how can you program it, right? So as you see here, guys, we have LCD. You know, there are different types of LCDs, by the way, right? But our LCD, it has 2 rows. As you see, this is 1 row and this is second row, right? Some LEDs has more, right? So it has 2 rows. Every row has 16 character. So this one 16 character and 16 character. So you cannot display more than 32 character, right? 16 and 16. Unless you do something like rotating text, right? But at the same time, I can only see 16 and 16, right? Is that okay, guys? So let me now explain it. I'm going to explain how it is connected. How can you program it? At least you know something I already mentioned earlier. I said if you want to display any character, so if you want to display letter G, letter A, letter G, you have to send the ASCII of this letter. Okay, so for example, in order to display number 2 here, you have to send 32, right? You have to send the ASCII of the, and already in chapter 2 you have the table for the ASCII of every character. So every character has ASCII, by the way, guys. Even space, you know, space has ASCII, right? Even plus, even minus, or everything, even if slash, backslash, whatever, right? So if all of them have ASCII, just I want you to go to chapter 2 to see asterisk as well. So everything, even space, you got what I'm saying, have ASCII. So you can just to go and see what is the value for each one. Again, the ASCII code is something like global. Everybody uses the same table, right? Even in your keyboard. That's why if you buy a keyboard made in China, made in Taiwan, made in US, wherever it is made, all of them should work, right? Because all the keyboards use the same table, right? Otherwise, they're not going to work, right? So, so let me now, yes. So now I'm going to go to the LCD. number one, I'm gonna tell you how it is connected. So this is again, I told you there are different kinds of LCD. This is not ours. So because this one has how many lines? 1, 2, 3, 4. So there are different types. The good thing is, if you understand how one LCD is programmed, the other ones usually they should be the same way, right? So there may be some small differences, but that's why if you want to program, I'm gonna for sure what I'm gonna program, what I'm gonna explain now is for our LCD, right? However, if you try another LCD, you have to look at the data sheet of this LCD to tell you how to program it. But the good thing is you will see a small difference. Almost all of them are the same in the way you program them. Okay, so let me tell you how they are, how it is connected to the microcontroller. So this is our microcontroller, guys. This is the LCD. Number one, it is connected to port K. We have port K. Okay, so as you see here, we have one pin. We call it RS. Okay, I'm gonna tell you what this pin is doing. Okay, we have another pin. We call it enable pin. Also, you will understand how this one is used. So this pin RS is connected to PK0. E, the enable, is connected to PK1. Also, here we have PK2 to PK5. So now, if this is port K, so I use 0, 1, right? And then I use 2, 3, 4, 5. So total, I need 6. So this is 4. These 4 are connected here, right? And then 1 bit and 1 bit, right? 1 bit here and the other bit here. Okay, guys? So in total, we use 6 bits, or if you want to say 6 pins, please don't be confused. They're almost the same, right, guys? Please don't be confused, because every bit should have a pin, right? So as I explained before, if this is your microcontroller, if this is port K, so you have here pins, right? And then if I talk about port K, which we use here, yeah, port K, use the word port K. So if you think about port K, it should be every pin here is connected to one pin. So if I want to output 5 volt here, I have to put 1 here. Okay, so please don't be confused. When I say bit, I mean this bit. When I say pin, I mean this one, which is actually almost the same, no difference, right? Because every time I write something, it's going to be shown here right away. So don't be confused. There is no difference. When I say the pin, the only difference is here I should say 1, right? Because this is logic. Anything inside the microcontroller should I say it in logic. So 1 or 0. But here I should say 5 volt and 0 volt, right? Anyway, so don't be confused when I say bit or pin. I say it's the same thing, right? So anyway, so now this is how it is connected. Okay, hardware, how the hardware is connected. Okay, now look here, guys. Please listen to me. When I send, I told you before, if I want to display a character here, I have to send the ASCII of this character. Is that okay? One more thing, the ASCII of every character. Again, if you go to the table, in chapter 2, you can see the ASCII of any character is a byte, right? So every character has a byte. Byte means 8 bits. This is the ASCII of any character. Okay, guys. So so number one, how to use this 4? These are 4 bits, right? These are 4 bits. Okay, here you can, this is where you send the byte, your data, right? For example, I want to display number 0, so you have to send 30, right? 30. So where? So I have to send it here through these pins, 30. But that doesn't make sense. Why that doesn't make sense? Simply because this one here is 8 bits. It's a byte, 8 bits, right? However, here we have 4 bits, 4 pins, 4 bits. So how I can send 8 bits through 4 pins, right? The way, yeah, you are right. This is a very good observation. You are right, right? So the way you are going to do that, guys, is I'm going to do it twice. So this byte, I'm gonna cut this byte, right, into 4 bits and 4 bits, right? So this is, for example, here I'm talking about number 0, 3, 0. So I'm gonna send these 4 bits first, right? Because we have 4 bits here, and then I'm gonna send the other one here. So I'm gonna do it twice, right, guys? Again, that doesn't mean every microcontroller has to be this way. No, I'm explaining this microcontroller. Sorry, not microcontroller. That doesn't mean every LCD has to be this way. I'm only explaining this LCD. So this LCD, because it has only here 4 bits, and I have to transfer a byte, I have to send a byte. So what I'm gonna do, if you have a byte, okay, which this example is the ASCII of a byte, of a number I want to display, or a character I want to display. So this byte, I'm gonna split it into 2 parts, 4 bits and 4 bits. You got what I'm saying? And then I'm gonna send the most significant 4 bits first, and then I'm gonna send the least significant 4 bits after that, okay? Twice. Again, some microcontrollers are not this way, okay? So some microcontrollers, you can have here 8 bits. 8 bits or 8 pins, whatever you want to call it, 8 pins, okay? So that means if you have a byte, you can just send it at once, right? At one time, right? Is that clear, guys? So now you understand now how I'm going to use these 4 bits. These 4 bits, these are where you have to send the data you want to display to the LCD. Also, I answered another important question. We agreed that all the ASCII characters are bytes, right? Bytes are 8 bits. So now the question is, how can you send 8 bits through 4 pins, right? As I told you, are gonna cut 4 and 4, okay? So it's gonna be 4 bits and 4 bits. That's what I said, right? So now I already answered the first question about what are these? How can we use these ones? Okay, this number 1. Number 2, that's why look here, guys, it's called 4-bit pass. 4-bit, because you can, it has 4 bits. But again, not all of them are like this. That some of them are 8, so you can send just at once. Can be easier, right? But anyway, also keep in mind, if you make it 8, guys, if it is 8, yes, it can be, the programming can be easier because you can just send to the byte once at one time, right? So you don't need to cut into 2 pieces. However, it's gonna take eight pins from the microcontroller. Again, the problem, guys, is the microcontroller, it does not have too many ports. Okay, that's what you should understand, right? We don't have too many ports, and I have to connect any input-output device to the ports, right? So this also can make a problem anyway. So now we understand what this part is. Okay, now tell us, what about these 2, right? So this is enable. I'm going to tell you how it is used, but before I explain this one, let me explain you the first one here, RS. So what is RS here, guys? Okay, look here, guys. Actually, what we send to the LCD, we can send to the LCD a character. Okay, that's what we call data. You can send data or character, right? And this one has to be ASCII, as I explained, right? It has to be in ASCII, right? Also, that's what I didn't explain yet. Also, you can send a command, right? So here, what I'm saying, what you are sending to the LCD, you can send a character to display, the ASCII of a character to display, or you can send a command, right? So what do you mean by command? Command, we have too many commands. Like one command, for example, you can clear LCD, you want to clear it. So this is a command, right? You have command, you can turn the LCD on, okay? You can turn it off, and we have more, as I'm gonna explain, we have many commands here. I'm gonna explain them later, right? So we have many commands you can send to do something, okay? So for example, you wanna move the cursor to the right, you wanna move the cursor to the left, and so on. So all of these are commands. Anything other than character you will display is a command, right? So anyway, so what I'm saying now, guys, what you send in both cases, in case of command or in case of data, what you have to send the byte, right? So every command should have a byte. I'm going to explain it later. Right now, so for example, I'm going to tell you, if you want to clear LCD, you have to send this byte 00001. So this is the code for this command, right? So let me summarize what I said, guys. What I said very easy. Okay, again, what we said to the LCD, you can send command or you can send ASCII for a character you want to display. That's what we call data. So you can send to data or you can send to command, right? In both cases, what you send the byte, a byte and a byte, right? So data, that every letter or every character you want to display is represented by a byte. Same thing, every command you want to do is should have a code which is a byte. Okay, guys, is that clear? Now, let me ask you a question. So, because this number here and this number here may be repeated, maybe it's the same number here, it should have, it is asking for a character, right? So the question is, how the LCD can know if you are sending is a command or a data, right? Because the same number can be a command, also can be asking for a character. So if I send a number here, a byte, how the LCD can know if this byte is actually for a command or for data, right? The LCD cannot know, right? So I have to tell the LCD this is a command or this is data. That is why we have this one here. So they made this pin so that before I send the data or our command, before I send a byte to the LCD, I have to tell the LCD what is coming to you. LCD is data or it is a command. How? This way. Look here, guys. So if you put here 0, that means you are telling the LCD what I'm sending is a command, is not ASCII for a character, right? Or if you put 1, you are telling this is a data or the ASCII of a character, and you have to display it. Is that clear, guys? Any question? So now also we understand. You understand why we need this one, right? So we need this one again because this one can be 0 or 1. If it is 0, you are telling the LCD what I'm gonna send you here. It's a command. If you put 1, you are telling the LCD what I'm gonna send here is data, and so on. Okay, guys. Any question? Is that easy? Okay. Now, just give me 1 second. Okay. Now the last part we have here is the enable. I'm gonna tell you why you have enable here, as you will see right now, guys. I told you if I want to send a data or a command, you're actually sending a byte. And I told you this byte, I'm gonna cut it into 2 pieces. So I'm gonna put the most significant byte here. Okay. So now the question is, once you put the byte here, how the LCD can know that there is some data available here and it has to go and get it? You got what I'm saying? You remember in memory, in RAM, we had one input, we call it read or write. I told you after you put the address, after you prepare in everything, the memory is not gonna work until you give the command to the memory. You're telling the memory read or write. Same thing here, but here it is in enable. You got what I'm saying? So enable means, what as you see right now, in enable, you have to make a signal something like that, a pulse like this one. Every time make a pulse like this one, you are telling the LCD there is something here, go and take it. You got what I'm saying? So let me tell you the conclusion now. The conclusion is, look here, guys. Number 1, here I have to put 0 or 1, right? That's very easy, 0 or 1, right? It depends if you are sending data or byte. You have to put 0 or 1. Sorry, if you're sending data or command or data, right? You put 0, 0 or 1. This is number 1. Okay, guys? Number 2, whatever you are gonna send, right? There is no difference between command and byte other than this one. everything after that is the same. I have a byte. This byte, I'm gonna cut it into 2 pieces. I'm gonna put this one first, right? And then I have to make a pulse here to tell the LCD, please LCD go and take it, right? So this is step number 1. Step number 2, I'm gonna take this one, I'm gonna put it here, and then I'm gonna generate another pulse to tell the LCD go and take it. That is exactly what we are gonna do right now. Is that clear, guys? So we're gonna put four bits, then you generate a pulse on the enable just to tell the LCD read, go and take it, right? And then you put the second one and generate a pulse. By this way, I already sent a byte. And then here I told the LCD if this byte is a data or command. Okay, guys, any question? Fantastic. So now let's explain now similar to what I did here, guys, in the keypad. I explained everything in details. However, I told you for the purpose of this course, yeah, it's good to learn everything for sure. We are here to learn. However, all what I need from you is how can you program it? Okay, so only programming, that's what I need. But still, it's good to learn everything. So in order to program the LCD here, guys, you have a number of functions. You should know how can you use them. This is the most important part. The second part is how they are programmed. Okay, and that's what I'm gonna do right now. So right now I'm gonna explain, guys, I'm gonna explain the first subroutine. We call it put character to LCD. Put character to LCD. Number 1, what this subroutine is doing, you can tell from the name. This subroutine, okay, before you call the subroutine here, you have to put the ASCII of the character you want to display, put it in register A, and then call the subroutine. That's it. This is how can you display a character. If I want to display a character, for example, I want to display letter A. So how I can do that? Number 1, you have to put, you can say, for example, load accumulator A, okay, with number 41, right? So now I have to put the ASCII, which is 41. I have to put it in register A. After that, you can just call this subroutine. Once you do that, this subroutine is going to take this number, this ASCII, which is in register A, and it's going to display it. How? That's what I explained here, right? So this one, this is because this is data. So this one has to write 1 here, right? Then it has to split the byte into 2 pieces, and then it's gonna put them 1 by 1. That's exactly how the subroutine works. That's exactly what I'm gonna explain now. So look here, guys. So what I'm doing, number 1, guys, I told you there are 2 things here. Number 1, how can you use the subroutine? That's very easy. Just put the ASCII in register A and then call this subroutine. This one is going to display a character. It's very easy, right? Now, what I'm going to do right now, I'm going to explain how the subroutine works, right? So this subroutine works this way, as you see here, guys. Number 1, I told you it is 2 parts. This is the first part, and this is the second part, right? You will see right now the 2 parts almost the same. The only difference between the 2 parts, the first part is going to work on this part, on these 4 bits. The second part is going to work on these 4 bits. That's it. But everything else is the same. So as you see here, guys, number 1, I'm going to push A because I want to save A because I'm going to use it later. Okay? Because I'm going to change A right now. I'm going to tell you how I change it. So now, if you see here, I did AND operation with F0. So after doing this AND operation, guys, so if this is register A, so we are going to have here 4 bits. Yeah, these are what I'm looking for. And then I'm going to put zeros here. So I'm going to cancel the first 4 bits because I don't want them right now. Okay, I just need the 4 bits here. Okay, and then this is after you execute this instruction. And then I'm going to shift right 2 times, as you see here. So after I shift right 2 times, so now register A is gonna be something like that. Look here, guys, 0 0, and then the 4 bits are here, and then 0 0. The 4 bits are here. So the 4 bits should start from bit 2 to bit 5, right? And then I'm gonna send it to port K, as you see here, send it to port K. So someone can ask me, so why you shifted 2 times. I shifted 2 times, guys, because I want the 4 bits to start from 2 to 5. That is because here, as you see here, because the 4 bits should come here, and this one should start from bit 2 to bit 5. Is that okay? 2 to 5. That's why I shifted it 2 times. So now I wrote it to port K. So now what I did, what I sent to port K, guys, I sent. Let me clear this part as well. So what I sent to port K, I sent 0, 0, and then the 4 bits here, the most significant 4 bits here. Is that okay? Now, because this is 0 is for a command, so I should not keep it this way, right? So I have to put 1 here, right? Because this is data, not command, right? So that's what I did here. So here, RS should equal to 1. So I'm going to use bit set in order to put 1 here, because this is data, not command, right? So that's what I put here, 1. Okay, guys. So now everything is ready. So you already put here 1 just to tell the LCD what is coming is data. You already put the 4 bits here. So everything is ready, right? So the LCD, do you think the LCD is gonna read it by its own? No. I have to give it a command. I have to order it, right? So how I give a command to the LCD to start to read it, to take this value, just by generating a pulse here. That's what this is the next step. So if you look at the next step here, guys, so here bit number 2 is high. So I'm gonna pull bit number 2 high, and then I'm gonna wait for some time. So I'm gonna waste some time, and then I'm gonna pull it low, as you would see here. Pull it low. Very easy. Very, very, very easy, right? Right. Anyway, now I'm done. Now I am done with the most significant 4 bit, right? So I have to do the same. I have to repeat, do the same thing again, but this time it has to be for the least significant 4 bits. Okay, guys? Any questions? So let me tell you quickly. So here, this is register A. I'm gonna mask. I'm gonna put 0 here because I only need these 4 bits. Then I'm gonna shift it twice. So I'm gonna put here 0, 0, and then the 4 bits are here. Okay, and for sure there are 2 zeros here. And then I'm gonna send this value to port K, right? Now, after that, in port K, I have to put 1 in RS bit set, right? So I have to put 1 here, 1. Okay, because this is data. If you are sending a command, so this one should be 0, right? And then after that, I have to generate a pulse in order to order the LCD to read this value. To generate this pulse, very easy. Bit set, look here, bit set for pin number 2. So I'm gonna pull it high. Then I'm gonna waste some time, very, very little time. I'm gonna waste very, very little time, right? And then I'm gonna pull it low. That's it. So now, guys, I did half of the work, right? Now I have to do the second half. So if you look at the code, everything almost is the same, okay? But I changed it so that I can work on the least significant 4 bit. Look how I made it, guys. So I'm gonna repeat. So here you have register A. Now I'm gonna clear this part because I need this one, right? This is the first part here. Number 2, this time I'm gonna shift to the left instead to the right. I'm gonna shift it twice so that the first 4 bits are here, okay? And then this is the value I'm gonna send to port K, as you see here, send to port K, right? And then again, you have to make sure the BK0 is 1, right? Here, okay? And then I'm gonna generate a pulse exactly as I did before. Pull high, wait some time, pull low, right? Now I am done. So now I send the byte. At the very end, I'm gonna just wait a very little time. That is because a microprocessor is faster than LCD. So I just wanna give some time to the LCD so that it can finish the work and display the character. That's it. So this is the subroutine. Again, guys, all what I need from you is, again, I explained everything to understand it very well. But anyway, what I need from you is just to understand how can you use it. And that's very trivial. All what you have to do, just put a character, put the ASCII of a character in register A, and then call the subroutine, okay? By the way, some student may be confused here. you know when I have a hashtag, and then after the hashtag I have to put a number, right? 47, 80, whatever, a certain number, right? However, here in this example, I put uh, uh, I put it this way, okay, guys? So again, don't be confused. When you put it this way, you are asking the code warrior to convert it to the ASCII, okay? So again, so it is similar. So if I, for example, if I do something like that, A, right? So I don't want to bother myself and to go check what is, this is exactly equivalent to 41, right? However, who's going to do this conversion? Instead of doing it by myself, the code warrior is going to do it, right? So don't be confused when you see something like that. Okay, guys, any questions? Okay, let me ask you a question. So now, very easy, very trivial. All what you have to do, just put in register A the ASCII of the character you want to display, and then call put character to LCD. Very easy, very trivial, right? So this is for one character. If you want to display one character, right? For sure, if you want to display a message, a string, a message should have a number of characters. So you have to call this one multiple times, okay? And as you will see later, just to make it easy, I'm going to create another function, this function to display a string or a message, a complete message. And this function is going to call this function multiple times, okay? For example, if I want to display the word hello, right? So I'm going to, again, as I told you, I'm gonna explain later a function. You can just give hello to this function. This function is gonna display the word hello. You will see this function inside this function is gonna call this one. So I'm gonna get letter H sent to this one, and then E sent to this one. This inside the function, right? L sent to this one, L to this one, O to this one. So inside this function is gonna call this function multiple times, because you know a message or a string is actually a number of characters. Okay, guys, let me ask you a question. So what I did now is I displayed one character. Okay, so now what if I wanted, what if I want to send a command? I told you before, if what you are sending, if it can be a command or data. In both cases, you just sending a byte. In both cases, okay. So how the code will be different? How the code will be different? Look, very simple. The code is identical to what I explained right now. If you want to send a command, but there is only one difference. This difference is, instead of putting one here, because one means I'm sending data, you are gonna just put zero, because zero means you are writing a command. This is the only difference there, right? So that is why we have another subroutine. This subroutine is called command to LCD, right? So this subroutine is used if you want to send a command to the LCD. So all what you have to do is you have to put the code of the command in register A before you call the subroutine. Is that okay? By the way, I think I made a mistake. Next week is not this lab. Sorry for that. It's the week after, right? Because next week it's going to be about switches and RGB, right? The week after is going to be LCD and keypad, right? But we have a lab about keypad and LCD. If you do this lab by yourself, if you understand it, you should be okay. Or you can use keypad and LCD very well. Okay, so I'm saying what I'm saying, guys. Now I'm going to teach another function or subroutine. This subroutine is called command to LCD, right? Number one, how this one different from what I explained right now. This one is used if you want to send a command, right? This is number one. Number two, all what you have to do is just, as I told you, I'm going to teach right now. Every command should have a code, a byte, right? So all what you have to do, you have to write this byte in register A, and then after that you call this function, right? So look at the subroutine here. This subroutine is identical to this subroutine. The only difference is just this one. Instead of saying bit set, I'm going to say bit clear. That's it, right? Or even you don't need to put it, by the way. Why you don't need to put it? Because I already, when I shift it, I already put zero here. So it's already, there is a zero. You don't even need to put this one here, right? So that's what I'm saying here. The subroutine is identical, but and even I put bit clear instead bit set, but actually you don't even need to put it. But anyway, okay. So same thing here. Everything else is the same. Any question, guys? Okay. So now what I taught so far, guys, is how can number one, how the LCD is connected, right? Number two, if you wanna display a character on the LCD, how can you do that, right? And I explain the operation. All what you have to do just to call a subroutine, and subroutine is gonna take care of everything. I explain the details, even how this is done using the subroutine. Very, very, very interesting. After that, I explain also how can you send a command, right? Now, for every character, how can you get the ASCII of every character? That's very trivial. You already, there is a table. This table is in chapter 2. It's already, if you search for this table, you will find it online. So you already have a table. If you want to, this table should give you the ASCII of any character, right? Even a space, even if you want to leave a space, it has ASCII, right? As I told you, question mark has ASCII, dot, period has ASCII, everything has ASCII. Anyway, so now what I didn't teach yet is you told us we have some commands you want to send to the LCD, right? You just give us example what commands mean. For example, you want to clear the display. You want to more specifically, I'm going to give you what command is here we have, right? So, and you told us every command should have a code, which is a byte, and you have to send this code as LCD. That's true. So tell us, what is this number? What is the code here? And also, guys, what I want to tell you, although I mentioned in the beginning, here I'm teaching one LCD, right? However, the good thing, all of them almost work the same way, right? So, but you have to be careful here. When you have a when you get an LCD, guys, you have to look at the data sheet of this LCD, because maybe you are going to use a different numbers for the commands, because these numbers are coming from the the company that made this LCD. You got what I'm saying? So they made it so that when you send this number, the hardware is going to do display or whatever. You got what I'm saying? So it's almost everything is the same, but the only difference, maybe these numbers are going to change. That's why if you program a different LCD, you have to see what numbers they are using. The good thing is, for ASCII, for data, it's going to be the same, because this is something universal, global. Everybody is using the ASCII code, right? But commands, maybe this may depend on the company who made the LCD. Okay. Anyway, so now I'm gonna teach what is the code for each instruction. So this is a summary. So I put everything here. Also here I define the symbols I used here. So you can see here, sometimes I use some symbols here. So I define them here. Here I give you the details here. Look here, guys. The first one here, the first command is number one, ASCII one. What this command is gonna do. So if you go to the table here, let me show you again. The code is here, guys. From here, this part from P0 to P7. So this is the byte you have to send. Okay. So you don't worry about it. Don't worry about the last 2 bits, because always RS has to be 1 here, because you are unless you are sending data, is something different, right? But the code you have the code is just this part from here to here, right? So let's see what is written here. Look here, guys. If you send 1000, I'm sorry again. So if you send 10000, right? If you send this one, what this one is going to do, it's written here. Number one, this one is going to clear the display. So if you want to clear the display, number two is going to return the cursor to the home position, which is address number 0. So what do you mean by the home address? I'm going to tell you. So if you look at the LCD, guys, the LCD, I told you it has 2 lines. Every line should have 16. So 16 character, right? And this one also 16 character. Great, right? So, and also, if you look at the LCD, guys, there is what we call cursor. You know, cursor. So I'm going to show the picture of this cursor. Yeah, for example, if you see here, you can see here, cursor. So there is a cursor. So if you send to command number 1, what's going to happen? Number 1, you are going to clear the LCD, and then the cursor is going to come to the home location. So if the cursor is here, if the cursor is here, guys, and then you clear, so it's gonna come to the home location, which is address number 0, right? So this is address number 0. Okay. This is if you use this instruction. So this is the first code you should know. The first code you should know is just a number one here, right? And the way you can use it, guys, as you see here, you can just write 1 to register A, and then you call this subroutine. This subroutine is gonna clear the display, move the cursor to the beginning, right? To the home position here, so that when you write something, you are gonna write starting from here, right? One more thing you should know, usually when I write something, for example, if the cursor is here, guys, and I write letter A, for example, so you can see letter A, and then the cursor move to next position this way. So the cursor always can tell you if I write right now where it's gonna be displayed. Okay. So this is the first instruction. The second instruction I'm gonna teach right now, guys, is here. Yes, if you look at this one here, guys, next instruction, this one here. So you have to put 0, 0, 0 here, and then you have to put 1 here, and then this one asterisk means don't care. So whatever you put here, it doesn't matter, don't care, okay? So if you put 1 or 0, it doesn't matter. So here, for example, I'm gonna put 0. So by this way, this should become number 2, 0, 2, or 2, right? So what this one is doing, this one should return the cursor to the home position, right? So that means, so this one, as you see here, guys, if I write number 2 in register A, and then I call this function, this one is going to return the cursor to the home position, right? Without changing the content. When you write, you are going to overwrite what is written. For example, let me give you example just to be clear. If this is the case right now, hello, and there is underscore here, is that okay? If this is the case, once I execute this instruction, what's going to happen? What's going to happen is it's going to be hello, and then the cursor will come here. So you want to move to the cursor to the home position, which this is the home position is here, right? In the first line, the first location in the first line. So it's going to move to here, okay? And now, because the cursor is here, if you want to write, you are going to start overwriting whatever is there. For example, if I put the cursor here and I write letter A, so it's gonna be A, and the cursor move to here. So I'm gonna overwrite whatever is there. Okay, guys. I want to tell you maybe some of what I'm commands you might not need to use. Maybe you don't need to use. However, I have to explain everything. You got what I'm saying? Or maybe in some situations you may use all of them. So this is what this one is doing. If you don't see it is useful, you may not need to use it. That's okay. Let's see the next command. In the next command, guys, you see here you have to put 0, 0. How many zeros? 1, 2, 3, 4, 5. So I have to put here 5 zeros. Again, I told you don't look at these two. So I have to put here 5, 0, and then you have to put here 1. And now you can put some here 1 or 0 to do different things, right? So now I can change these 2 bits to do different things, but everything else is fixed, right? So now let me explain how it works. Now I'm gonna assume only look at the first 2 bits here, right? Because everything else is fixed, right? So here, assume I'm gonna put 0 here. That's okay. So look here, if I put here 1, what's gonna happen? If I put 1, what's gonna happen? Okay, guys. So if you put here 1, if you put 0 this way, okay, that means you are asking the LCD every time you write a character, you want the cursor to be decremented. So the cursor is gonna move to the left, right? If you put 0 here. But if I put 1, so you want the cursor every time you write something, you want it to move to the right. Okay, what this means? I'm gonna tell you what this means. For example, here we have the cursor is here, guys. Or for example, you have the word HELL and the cursor is here, right? So the second one here, you want the cursor to move to the right. And that's actually what we are going to use because you are writing English, right? So the cursor has to always to move from left to right, right? So if it is this way and I want to display letter O, so if I program it this way, and that's usually what we are going to do anyway, so you are going to see hello and then letter O, and then the cursor is going to move to the right, increment it, right? Move to the right. And this makes sense because that's English, right? However, maybe for some reason, I don't know, maybe for some reason, or you want to do something using the keypad, okay? You can ask every time you write something, the cursor can go to the left instead of the right, right? So for example, if you have here, as I explained, you have hello here this way. If I write O, okay, so it's gonna be hello, and then the cursor will come here. So the cursor, every time you write something, the cursor is gonna be decremented. Again, don't worry, you may not need to use this one, but again, this is some capability because sometimes when I use the LCD, guys, it's not just I write. Sometimes the people do some things like that are fancy. You want to do something like rotating text. You want to do something fancy. Maybe you need this command in this case, okay? But again, I'm going to teach you all commands. Some of them you may not need to use in most of the time. But again, this command here, guys, if you put here 0, right? And then this bit, the other bits are fixed, but if you put here 0 or 1, so this one can control every time you write something, do you want the cursor to go to right or to go to left? Most of the time we're going to go with this one for sure because we are writing English. So every time I need the cursor to go to the right? Now, so what this S is S. So S here, if you come here and see what is S, so this S here is actually if no display shift or you want to do display shift. So what this means? So actually, this means, do you want to shift the display or not? Okay, what this means again, shift the display. Sometimes I want to do something like rotating text, right? Maybe this is not very usual, but again, this is not the basic stuff, but again, this is something capability you can do. So for example, hello, if this is hello this way, right? I want to shift the word hello. So I'm going to shift it, right? And then I want to shift it again and so on, right? So every time you can shift it to the right or you shift it to the left. So who's going to say if you want to shift it or not? So this one here. So this one, you can say, when I put 0, that means there is no shift. I don't want to shift the text, right? But when I put 1, that means I want to shift the text. Again, maybe you don't need it much. Now, let's look at the next one here. Again, this is a summary here in this table. So I'm going to look at the next one here, which is very easy. Look at the next one here, guys. Okay, so we have 0, 0, 0, 0, 1. This is fixed. We're not going to talk about this one. Fix it. Now, you have three bits. Every bit can do something different. If you put 0 or 1, it can do something different. So let's see what they are doing, okay? So first, look at bit G here. Okay. Bit G, this one G, right? So this one you can turn on and off the display, right? And that's what actually you need in the coming lab. In the coming lab, I'm gonna ask you, turn the display on or turn the display off. So let's see how I made it here. Again, I told you I'm not gonna look at this part. This part is fixed. So now, I think, sorry, I'm talking about something different. So here I told you I'm not gonna talk about this part. This is fixed. So now I wanna tell you, I'm gonna take them one by one. So here, if you put here, this is D, which is here. If I put one here means, I'm sorry. I think, so here, yeah, okay, sorry. So here, everyone is doing something different, every bit here. So D, as I mentioned, so the D is correct. The D can be used if you want to turn the display on or off, right? The C is used if you want to turn the cursor on or off. So what this means? It means, do you want to see the cursor or do you want to cancel it? You cannot see it, right? It is there, but you cannot see it. For example, so here the cursor is on. That's why you can see the cursor, right? I can cancel it. You cannot see it, right? So, but once you write, you're going to write here. So you are going to write from here, but it's not shown. You can cancel it. So, okay, so who's gonna decide if you want to leave it or cancel it? Just this bit number C here, as you will see right now. The last one, bit number B, this one can control. We have two types of the cursor. We have stable cursor, which is going to be something like stable dash, something like that, or something like that here, underscore this way. So stable, or you can make it blinking. What do you mean by blinking? Blinking means everything is this way, is gray or whatever color it is, and then this one. So it's alternate between these two. So you can see it blinking. Okay, again, I have to explain everything, but this blinking, you may not need it, but it's very interesting. I want you guys, again, you have the program, you have everything, and you are going to do a lab on this one anyway. I want you to play with it and explore and see what blinking means. Do it just curiosity, out of curiosity, and see it. Okay, guys. So I'm gonna explain it here. How can you do that? But again, every bit controls something different. So let me explain them quickly. So here, letter C. I told you for C, guys. If you want, as the cursor is off, you just put here 0. This is C. You can put 0 here. If you want to turn the cursor off, that means you cannot see a cursor, right? If you put here 1, this is C. C is here. That means you turn the cursor on. You can see the cursor, right? Here, the first bit can control if you want this cursor to be blinking, right? Or it's not blinking. Again, most of the time we're not gonna, so blinking here is off. It's not blinking. If you put 1, you can make it blinking. Again, to make it easy for you guys, most of the time we're not gonna make it blinking, just stable. Most of the time you can use it this way, right? Most of the time the cursor is on. We're not gonna make it off again, but still you can make it off if you want. The last thing here, which is very important, is you can turn the display on or off. This is this bit here. So if you put here bit 0, right, that means you want the display to be off, right? If you put here 1, that means you want to turn the display on. You got what I'm saying? So let me explain to you, what do you mean by off or on? What this means? That's what you will do in the coming lab, and you will understand it better. On means you can see the text this way. So there is a text. There is a big difference between on, off, and between off and clear, right? Clear means you remove the text. You don't see anything if it's clear, right? Off, you don't see anything, but once you turn it on, you can see the text because the text is there, right? You didn't remove the text. So the text is already there. The message is already there, right? But if you off, you just, I'm gonna hide it. You cannot see it, right? But on, you can see it, right? I'm gonna show a video later about this. Very easy. Just if you know the code, just send the code. I'm just explaining what the codes we have here and how they work. That's it, right? The interesting thing you will learn in the coming lab, guys, is, so in the coming lab, week after the lab on this part, actually, I want you to get a number from the keypad and display it on the LCD, right? So you will discover, I want you to observe this or discover this. Even if you turn the LCD off, listen to me. If I turn it off, so I cannot see any text, right? If your program writes some data, is going to be written, right? But you cannot see it. Once you turn it on, you will see it. Again, what you are saying, very simple. I'm going to tell you what I'm saying. For example, you can see the word hello this way, guys, okay? And then I turn it off. So I don't see anything, right? So this is off. If I turn it on, you can see hello again, right? If I turn it off this way, right? What I'm saying, when you turn off and your program is working, that means you get a character from the user and sent to the LCD, is going to be written, but you cannot see it. That means, for example, if I take number 0 and I think 30, that means it's written. But once you turn the LCD on, you will see it. So I will see hello and then number 0, right? You will see number 0 here, right? Because off means I cannot see the text, but still if you can send something, it's going to be written, right? So this it shouldn't work this way, by the way. Your program shouldn't work this way. but we have a software fix, or you use it I recommend you to do what you can do if just yeah, just one second. So as I'm gonna explain later, guys, what I'm saying, if the LCD is off, your program should not write anything because it's off, right? It's not a big deal, but you can make the program this way. So once it is off, you have to wait. You don't send anything until it is on again, right? But anyway, I'm gonna talk about this one next time. Okay, thanks guys. Thanks. Bye. Any questions?